Easy STM32 PWM tutorial. Let's go. Step 1. Find an STM32. I found mine in the trash. I am using an STM32 F746ZG. Step 2. Go on Google and locate the datasheet for your STM32. Step 3. In the datasheet, look for General Purpose Timers section. Here we will look for a timer that is suitable for PWM use. Here I'll choose Timer 3, and we can see that it is suitable for PWM use. We then need to see what pin Timer 3 is associated with. This can be found on the pinout description section. Here we can see Timer 3 channel 1 is associated with pin PA6. Step 4. Find what physical pin it is connected to on the STM32. On Google, search the STM32 pinout and use the ARM embed site. It's the first link that comes up. Looking through the website, we can see that pin PA6 is connected to physical pin D12, therefore we will be using pin D12. Step 5. Make an STM32 project. Locate the board you are using. I am using the F746ZG. Make a C program called PWM and then wait several hours for the software to load. Step 6. Configure the timer and PWM settings. On the clock configuration settings, we can see that our STM32 is running at 72 MHz. H clock is the main STM32 clock. On the pinouts and configurations, we select the timer 3, and then we go to clock source and we select internal clock because that's the only clock we have available on our microcontroller. Next, we look at channel 1. We select PWM generation channel 1. In the counter settings, we can set the PWM frequency. The PWM frequency is equal to the STM32 frequency, which is 72 MHz, divided by the counter period plus 1, multiplied by the prescaler plus 1. Now for the prescaler simply divides the clock signal. So we have 72 MHz as our STM32 frequency. Now we can take that down to 10 kHz, which is a convenient frequency to use by scaling it down by 7,200. Now we use 7,200 minus 1 because a prescaler of 0 is a prescaler of 1 in the software. So if we use 7,200 minus 1, which is equal to a prescaler of 7,200. We now change the counter period, also known as the auto reload register. This is the value that the counter will count up to until it resets. It starts at 0, so we must do counter period minus 1. Now for a PWM frequency of 50 Hz, we can use a counter period of 200. We then select PWM mode 1 on the PWM generation channel 1. This ensures that our PWM is a normal PWM signal. Mode 2 is the inverse. If you look at the STM32 pinouts diagram, you can now see that on pin PA6 it says TIM3 channel 1. Step 7. We can finally start programming our main.c file. First save and generate code, and then we can start coding. In main.c, scroll down to the while 1 loop, and above you can see that there is an mx TIM3 init function. That is the function that initializes the timer 3. Now we managed to create a PWM frequency of 50 Hz. How do we create the duty cycle we want to? To do this, we have to set the CCR1 register of timer 3. As the counter value counts up, when it reaches the CCR1 value, then it will pulse down. This creates us a duty cycle for our PWM signal. Now, our duty cycle equals CCR1 divided by counter period multiplied by 100. So for a duty cycle of 40%, we can use CCR1 equals 80. So duty cycle equals 80 divided by 200 multiplied by 100. That equals 40%. Now lastly, we type in HAL TIM PWM start with timer 3 and TIM channel 1. This starts the PWM for timer 3 channel 1. And that's all the code you have to write. Now your PWM signal should be created. Now lastly, save your work, plug in your STM32 and run the code. Hopefully now your PWM signal should be created. Step 8. Check your PWM signal with an oscilloscope if you have one. Check that the duty cycle and the frequency is correct. I have connected my STM32 to an oscilloscope, and the oscilloscope reads 40% duty cycle and around 50 Hz. This shows this is a correct signal. And then the most important step of all, please like and subscribe or your STM32 will not work. Please comment if you like this type of video and if I should make more. Thank you.